Even as events in Oak Park threatened to upend his personal life, a new scientific challenge was drawing Percy Julian into one of the great medical dramas of the 20th century. At the center was one of the oldest and most painful of human diseases, rheumatoid arthritis.
Arthritis is a generic word for inflammation of the joints and encompasses a lot of different diseases. But the disease that truly inflames the joint and causes destruction of the cartilage and the bone within the joint is rheumatoid arthritis.
Scientists had been seeking a cure for rheumatoid arthritis for hundreds of years. But by the middle of the 20th century, those efforts had yielded only a bizarre assortment of mostly ineffective treatments. Chin slings, gold injections, mineral baths, cobra venom, bee stings, even electricity.
People would swear by them, but nothing over the long run worked.
The situation changed dramatically at the 1949 annual meeting of American rheumatologists. Philip Hench of the Mayo Clinic presented a film showing how arthritis patients responded to a new drug called Compound E, and later named cortisone.
They were severely crippled, having to drink by holding a cup in both hands. And Philip Hench gave them an injection, and within 12 to 24 hours, the same patients were having no difficulty at all. It was one of the most astonishing things that has ever happened in medicine. You didn't need a double-blind study. You just saw it happen. And the audience stood up and cheered. Well, every patient with rheumatoid arthritis immediately wanted to be put on this magic drug.
The problem was, there was none to be had. Hench had performed his tests with a few precious grams of cortisone sent to him by Louis Sarret, a young chemist at Merck. Sarret had worked for years to synthesize cortisone from the bile of slaughtered oxen. But his chemical pathway was the most complex ever attempted in industry, requiring more than 30 steps, and thousands of cattle carcasses would be needed to make enough cortisone to treat a single patient for a year. To treat the millions suffering from rheumatoid arthritis, scientists would need to find a more plentiful starting material and simplify the process of producing cortisone. Chemists from all over the world sprang to the challenge, launching one of the most intensive research efforts in the history of medicine. Julian threw himself into the effort.
The only reason that Glidden is in the great cortisone race is because of Percy Julian. He knows this chemistry, and so he can establish a position for them. The American pharmaceutical industry after World War II is not the giant that we know of today. This business is really just getting going. So there is room for entrepreneurs in this period.
One of those entrepreneurs was Carl Gerasi, then a young chemist at Syntex, the small Mexican company that made hormones from yams.
Julian and I were competitors, and we were in this race with people at Harvard and at Oxford and in Zurich and at Merck and all the major companies. It was one time when basic research in industry competed on equal terms with that in universities.
The prize these chemists were after was not actually a drug, but a natural hormone. Cortisone is one of the many hormones made by the adrenal glands, two small organs that lie atop the kidneys. Small amounts of cortisone are always circulating in the bloodstream, controlling the body's responses to stress and inflammation. but much larger doses of cortisone were needed to relieve the symptoms of arthritis. Julian hoped to make cortisone from soybeans, just as he had the sex hormones. Like progesterone, cortisone has the same 4 interlocking rings of carbon, known as the steroid nucleus. But cortisone has an unusual feature. One of its oxygen atoms is in what chemists call position 11. Julian set out to make cortisone by first synthesizing an almost identical compound called Reichstein's substance S, or compound S.
Look at the two formulae. Compound S differs from cortisone by one lone little oxygen atom. And it couldn't possibly be so strikingly different in properties, I thought. And if it is, why in the devil did nature have to put so much in the adrenal glands? And if you really think nature is smart, your guess would be that it's there as a reservoir from which the adrenals can make cortisone as the body needs it by simply sticking in this one oxygen atom.
Julian hoped to convert compound S into cortisone as the body does. But he knew that inserting that one oxygen atom in exactly the right place would not be a simple matter.
In the body, there's a special enzyme that knows how to do this and does it very elegantly in a simple reaction. But to do this chemically in the lab in large quantities was fiendishly difficult.
In the laboratory, in order to add any atom to this carbon atom, requires severe conditions. High heat, high pressure, very reactive reagents that will attack this atom. The difficulty with those conditions is that they will attack every other carbon atom on this skeleton as well.
You want to put the oxygen only in that position. It doesn't do you any good to put it there if simultaneously you put it somewhere else where it's not supposed to be.
Chemists across the world faced the same challenge. Whatever material they started with, plant or animal, they had to find a way to insert that one oxygen atom into just the right position. This was the single biggest obstacle to making cortisone. As Julian struggled to find a solution, Glidden executives were losing patience with his compound S approach.
It's hard to read another chemist's mind, but I think that Julian probably knew that this was so close to the final structure of cortisone that if he could make substance S in large quantities inexpensively, he would eventually, or someone would eventually, find a way to insert that troublesome oxygen into the 11 position, because that was the only remaining step needed to convert that substance into the full-blown hormone cortisone.
But the problem of inserting that one oxygen atom continued to frustrate chemists for more than 2 years. The cortisone shortage became a crisis as the price topped $4,000 an ounce, 100 times the price of gold.
I would get requests from all over the country. Can't you get me some cortisone? Can't you get me a little cortisone for me, for my aunt, for my patient? And I couldn't get it for me or for anybody.